Hello, folks. Welcome to Rational Science, directly from Germany. I've been sick for the last 3 weeks, especially the last 2 weeks. Got a congestion I can't get rid of. Just a moment ago, I took an aspirin and some nose drops, see if I can talk a little better today than last time. Anyways, and I've been on the road, so haven't been able to see a doctor or anything like that. So we'll find out what's going on. Uh, for the last couple weeks or last couple times, we've talked about the flatlanders. Okay, who are the flatlanders? Here, let me synthesize that. Okay, these are the flatlanders. We got people anywhere from the flat earthers, they're on the right, all the way to the flat universers on the upper left. All these people believe in some kind of, they have some problem with pancakes, I guess. They think everything's flat. Then in between, you have people like, the people who talk about dimensions and 2 dimensions, 4 dimensions, all these dimensions. And they make a good salad with that. And also, we have the quantum mechanics, the etherists, and the electric universers. I include them under flatlanders because they what they propose, their theories, what they propose how the universe works. I think a lot of that belongs all in flatland. Anyways, today specifically, I'm going to be dealing with the etherists here. Okay, and the reason is, they raised quite a few, or put several comments. They raised a lot of questions, and so I want to address a lot of their misconceptions. Okay, so let's start with them. First, Etherist, right? He says the following. So somehow this channel turned from a really interesting alternative physics channel to a hate spewing, I know better than all of you channel, which makes it impossible to have a serious constructive discussion on topics that help humanity. Okay, frustrated fellow. Okay, okay, so this is what I got to say to this gentleman. Okay, and here it goes. This fellow's a frustrated etherist because he can't defend his beloved ether. Okay, that's what it's all about. That's why instead of addressing substance, he went after form. He says, "Oh, you said poo-poo, Bill. Yeah, if you put more emphasis on form than on substance, I suggest that you go visit Mr. Juanito Baez there at the University of Riverside." And the University of Riverside is partially maintained by the state. In other words, state funds. And why is that important? Well, that means your tax dollars are helping to support its operations. And there you will find, for the last 20 years at least, the crackpot index that Mr. Baez put up there. So it's officially on their website. And it's used to demean, to make fun of, to ridicule anyone who opposes, especially quantum mechanics and general relativity. So if you oppose mathematical physics in any way, shape, or form, oh, they will set you straight. And the way they will do it is by laughing at you, by ridiculing you, by calling you a what? A crackpot. Okay, you're a crackpot. They wouldn't even listen to you. Okay, and I like point number 19 in Baez's crackpot index says 10 points for arguing that while a current well-established theory predicts phenomena correctly, it doesn't explain why they occur or fails to provide a mechanism. Yeah, Mr. Baez, that's exactly what physics was supposed to do. All the questions that people ask, for example, in Quora or even in this site, have to do with mechanisms. And these people give the most irrational answer they can think of as far as mechanism and theory are concerned. And here he says, well, it doesn't explain. Well, who cares? They don't believe that's part of their job responsibilities. Okay, they think all they have to do is just describe, not explain mechanisms. So anyways, you're paying for this, for these people to make fun of you. So if you have a gripe against form, don't come to my channel. Go to Mr. Bai's channel. Go to the University of Riverside. Send them a letter and tell them, hey, how come they use that crackpot index to belittle anyone who opposes mathematical physics in any way, shape, or form. Then he says, really interesting, he hasn't understood a single thing, and especially in my criticism of ether. Okay, constructive, the construction part has to do with substance, not with form. So, if you want to be constructive, what you should do is answer the question, what is the ether? And I think I made that quite clear. I'm going to make it again clear today, just in case. Help humanity? Absolutely not. What do I propose here? I'm saying that we are the last humans on Earth, so there is no intention on my part to help humanity. More specifically, we're here to destroy mathematical physics, not to construct anything related to anything that's come out of mathematical physics in the last 400 years. Okay, so let's find out what this site is about. This site is about destroying mathematical physics and every one of their theories, every one of their explanations, physical interpretations, which we dismiss as absolute nonsense, irrationality, poppycock, and replacing it constructively, right, with the rope model. And now you have mechanisms that you can sink your teeth into. You don't have to believe it, but hopefully if you come here, you understand it. That's all. That's our only hope, okay? We cross our fingers that you will understand it. Okay, here's another etherist, and he says, greetings, Bill Gates. You're an ignoramus, blah, 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 blah. Okay, and I just pointed out that he misspelled your, okay? They say, you're a sad old piece of work, okay? Again, that's twice now that he misspelled your. So I don't know if he can talk about ignorant, okay? What does he propose? The ether is the medium. Now, I have more respect for people like him, okay, than the previous guy, because this guy's speaking from the heart, okay? And, you can come to this side, you can put any comment you want as far as I'm concerned. You can cuss my mother if you want, okay? I don't really care. If you have something to say, something that's interesting, something that I think deserves attention, to be addressed, then I will address it on the next, lecture. But you can come here and put anything you want. In fact, I encourage you to do so because I know you're speaking from the heart. You're being honest. But when you come in there and you say, well, Bill, you said poo-poo and I got offended, you're in the wrong side, buddy. You're in the wrong field because, you got to think about something, since the days of the Greeks, one school of thought would laugh and ridicule another school of thought. Nothing has changed in the last 3,000 years. Okay, so if you just found out that, hey, you offended me, first of all, we don't offend. We treat you with the respect that you deserve. But even if we offended you, that's exactly what the establishment does. All of science is like that. And they have different ways of offending you, quotations on that. One by not publishing you. How's that for offensive? And the other one is, they laugh at you, they belittle you, and you can't get your word out there, okay? That's if you're against the establishment, right? So there's no way to beat that because they have all the funds, they have all the controls of the sources of power, and you're just a little guy, you're nobody. That's the status quo. So yeah, at least let me make fun of them, okay? That's my little revenge against these people. Okay, another fellow says, an ether is here. He says, the ether is not made of particles. It's ubiquitous, continuous fluid. The ether is not composed of anything. Okay, we got a little bit of a problem, or at least we're not understanding exactly what this fellow proposes, because there you see a fluid, and it seems like it's made of parts. Okay, so if it's like he says it's just continuous, whatever he means by that, we say that means made of a single piece if it's not made of parts, right? then this is what he's got to answer. There's your ether. It's made of a single piece. In this case, I put a block, an elongated cube, no problem. You can put a sphere if you want, put whatever you want in there. You can color it any way you want as well. I'll call that the ether. It's a continuous block made of a single piece. I need to know what the white stuff is. I don't care about the block. I want to know what gives shape to this single piece entity made of a single piece. Okay, so unless he can answer that question, he's said nothing so far. Okay, how about another fellow? He says the following. Let's see if we can get him up here. Says the ether is made of an infinite amount of infinitely small objects. In other words, the first guy says it's not made of parts. This guy says it is made of parts. And that gives you an idea of where all these etherists stand. You can't get a single group of people to agree on what the ether is because they've never pondered what the ether is. They just want to use it. They say, well, it's this. Oh, okay, yeah, I understood a lot with that. Okay, so it says the ether fills all of space, nothing. Well, it can't fill space because space is not a container if you're going to define space as nothing. Nothing is not a container. Something is a container. So the ether cannot fill all of space, first of all. Second, you haven't told me whether the ether or space is infinite, meaning extends forever or not, or if it stops somewhere, what's on the outside of it. And we have the same situation as before. You got to tell me what's outside of the block. Waves are not objects, they are motion. Okay, he's right about that, correct. And he says in the case of light waves, it is the motion of the ether. Now I've got a little problem there, okay. He says in the case of light waves, it is the motion of the ether. Okay, so there you have the ether. It's made out of infinite amount of small particles. Okay, that's what he's saying. Apparently he's saying that it's some kind of physical object, therefore it has to have shape, it has to stop somewhere, it's got to be finite, right? Made of infinite particles, but it itself has to be finite unless he can, otherwise it's not a physical object. Okay, it's not a thing. You can't use it as a thing. Okay, so what's the problem with what he's saying here? He says that is the motion of the ether. Okay, so let's start slowly so that you can understand the reasoning. Okay, here we have a table, and we have a portion of the table, and it's waving. Okay, some portion of the table is waving. Can you say that the table is waving? Okay, because these people say the ether is infinite, it's extended, it's the whole universe, it fills up space. The ether is vibrating. It's the motion of the ether. Well, here we have where the problem is. You can't say that that portion of the table, that region of the table, which is moving there, it could be atoms, could be the crystal structure of the table, could be the wood, could be whatever. But I'm saying there's a region of the table that's vibrating. And so the question is can you say that the table is vibrating? Or should you say that a region of the table, a segment, a part, a portion of the table is vibrating? Okay, so this is the issue. Okay, now here's the ether. Okay, can we say that the whole ether, the whole universe is vibrating? Or is light the vibration, a localized vibration of the ether? In which case, you have light going this way, you have light going that way, and light going in different directions through the ether, or being the ether itself that's vibrating, no problem. But then that means it's made of parts. That's the first one. Okay, it's, like he said, infinite amount of part. No such thing as infinite in science because he's using the word infinite, which is an adjective to qualify not the particle. He's saying that there's countless. He's saying that's incessant counting of particles. That's what he means by infinite. Infinite can only be an object, and all objects are finite. Therefore, the word infinite is an irrational term, should never be used in science. So these people have not understood how to talk. That's the first problem. They're using adjectives to qualify counting, which is, in this case, turns this adjective into an adverb. Okay. Okay, let me remove this. Give me a second here. Okay, here we have another etherist along the same lines. He says, yes, if a portion of the ether vibrates, that is still the ether. Okay, same issue. Just as we would say that sound wave is a vibration of the atmosphere when only a part of the atmosphere vibrates. There is no parts and ether. The ether is the parts. Okay, so same issue. Here we have the table. Is the table the same thing as the part of the table? I mean, if we talk about one of the legs and we call it leg, right, of the table, is leg the same thing as table? And this is the issue here. And here we have a portion of the table that is vibrating for whatever reason. Only one portion. It's made out of liquid or whatever. Can we say that the table is vibrating? And once again, can we say that the ether is vibrating here? Is it the whole universe that's vibrating here? So this is the issue. The issue is these people are confusing a portion of something with that something itself, with a whole something. Okay? You're not allowed to do that in physics. You have to identify the region and you have to give it a name. So we can say the ether, and now we have A. A is not ether. A is a portion of the ether, localized region, and you have to identify what it is that's vibrating. You can't say it's the ether vibrating. No, what you have is maybe particles that are going up and down. And if they're particles, which is what they usually imply when they say that's made out of countless parts, right? Then they have to tell me, what gives shape to each one of those parts. In other words, what's the black stuff in this case? The white stuff are the parts. What's the black part that keeps separated all these parts? So until you finish defining exactly what you mean by ether or illustrating it, we have no idea what you mean by ether. Okay, these people want to, go through this real quickly, like, yeah, it's a fluid. It doesn't work that way in science. You got to spend 2 years explaining to us or illustrating what the ether is, right? And then we'll listen to your irrelevant theory about gravity or whatever you want to explain. Spend time on your ether. We don't know what the ether is yet. And we have all these different opinions, different versions. Okay, so be very clear. It's very easy to also put a link to either your website or some other website where they have an illustration of the ether if you want to illustrate the ether. No problem. Okay, but what I do recommend is for do an images search in Google and look for the ether. Put ether in there. You'll see what people have in their minds, what they think ether is. You'll find 100 different versions. So now nobody has any idea what the ether is. That's why I like to tell them what the ether is. And if they don't like it, they have to tell me why my ether is not their ether, or the traditional ether, the one that was used in the 19th century to talk about the undulation of light. Okay, here we have another fellow that says ether can be treated like a continuum. At all levels, because it is made of what? An infinite amount of objects. So this fellow thinks that a continuum is simply something that is made of an infinite amount of things. Okay? So I have to define for him what continuous means, because people use these words, they don't even know what they're talking about. Continuous is something made of a single piece. That's what continuous means in physics. I don't care what it means in the religion of math. I don't care what it means in everyday speech. Continuous in physics, made of a single piece. It's an adjective. It refers to an object that is made of a single piece. Okay? Now, what these people want to do is use the word continuum, continuous, continually. They want to use it as perpetual or eternal as synonyms of these words. It could be perpetual, means that it doesn't stop moving, or eternal, never stops existing. Okay? Like it's, at some point something stops existing, or disappears somehow. These people are saying that eternal essentially is never stops existing. And here you have synonyms of these words, more or less: incessant, constant, nonstop. Here we're talking about motion. And they use the word continuous to talk about motion. That's where the problem is. Continuous can never be used for motion. Okay, so this is where the problem is. And then you have endless, like if you're talking about an object, okay, that's an infinite object. And there's no such monster, because an object is that which has shape. Therefore, it's an oxymoron. It's a self-contradiction to say an endless object or an infinite object. And in the religion of General Relativity, they use the term finite but unbounded. And again, the finite part usually refers to the object. All objects are finite. But when they talk about the unbounded, which is an adjective, bounded, it's an adjective. Should be used to, again, it means an object that has no shape, because you can't see the shape. You can't see how it's bounded, okay? But what they use unbounded for is something totally different. And it's, again, it's used for incessant as a synonym of incessant or perpetual. They're saying that the motion around the object is unbounded. You'll never find a wall. That's what they mean by unbounded. So they try to get this duality through to you, saying it's finite but unbounded universe. No such monster in physics. Okay, they have a contradiction in their terms. They're doing word salad, as it's called, semantics. Okay, so continuums aren't actual objects, but rather mathematical representations of a group of objects. What? Behavior. Okay, so is continuum related to behavior or to objects? Okay, so we have a problem here, because this fellow goes back and forth. He doesn't even know what he's saying. If it's got to do with behavior, then they should not use the word continuum. And then he clarifies, says a continuum is not an actual fluid, because fluids are made of more than one thing. Okay, I thought that's what they define continuum as, something made of many things. Most ether theorists have defined ether as being made of many, possibly infinite amount of particles. Again, all these people use the word infinite when infinite is an adjective, should never be used in science at all. Anytime a person uses the word infinite, we call him an idiot. Idiot is a person with big ideas. Okay. And no, we're not offending them. We're treating him with the respect that he deserves. Okay, here we have another fellow. He says, you're still messing with the usual word salad. Again, he thinks all this is just semantics, okay? My ether mechanism about fluid dynamics, very rational. So he declares his own theory very rational, okay? Yet you totally reject and mock the ether. Yes, until you do the word salad semantics, okay? These people want to avoid language, because they're not good at all. They don't define words at all. They don't care about definition. They say, you know what I mean by ether. No, I don't. And so we need for you to tell us exactly what you mean by ether. And if it's an object, we want you to point to it. We want a drawing. We want a picture, snapshot, whatever you can get, a statue, bring it to the conference. And he says, take the damn time to read. And I answer, take the damn time to listen. Because he says, you still haven't answered the question. Tell me what your ropes are made of. It's already been 2-3 times that I said rope is equal to 2 threads. 2 threads. You go to the hardware store, you ask for a rope. What will they give you? Well, they'll give you maybe, if it's a 2-strand rope, right? They'll give you 2 twined threads, strands, wires, whatever you want, strings, whatever you want to call them. 2 threads, okay? That's what a rope is made out of. If you've never learned that in kindergarten, please go to your nearest hardware store and ask for a 2-strand rope, and you'll find out what a rope is made out of, 2 strands. But this is what these people have to answer, okay? And this is what none of them can do, and they haven't done so far. These are their action items. Is it an object or a concept? And if you don't know the difference, well, you gotta go to kindergarten and learn what an object is and what a concept is. Object, just in general terms, is that which has shape. Concept is that which doesn't. That's not the definition of concept, but we need to know if what you're referring to has shape or not, essentially. Concepts we define, objects we illustrate. We do not illustrate concepts. We do not define objects. You do not define table. You point to it so that the Klingon knows what the word table refers to. Okay? Then you got to tell me whether ether is equal to space or ether is not equal to space. Okay, right now we have different opinions out there what the ether is. Okay, whether ether and space are synonyms or whether ether is something contained within space, right? And again, is space equal? Is space finite? In other words, is the ether finite? And if space is the container, we need to know what's containing space, because if space is a container, it's a physical object. Like your trash can, that's called a container. And there's something outside of that trash can to give it shape. Okay, we need to know what that outside thing is. That's the one we're interested in. Is it made out of a single piece or made out of particles? Does it have motion, this ether thingy, with respect to what? And again, is it the ether or a region of the ether that you're going to be moving? Okay, and again, here we have the comparison. Okay, if you can't say the table is vibrating, it's a portion of the table that's vibrating. If that's your notion of the ether, we need for you to identify very well what it is that's vibrating. In the case of the ether, what is that squiggly line that's moving, that wave? If you say that the ether is vibrating, you're saying the whole universe is vibrating. That's not what you're referring to. You're saying a region of the ether is vibrating. For that, you need to identify that region. Tell me what it's made out of. What's the white stuff? What's the black stuff? Okay? You need every little thing. You can't just skip and say, well, it's the ether. That doesn't solve our problem. Okay? Okay, and finally we have another fellow. He says the following: space is nothing. That is my definition. I literally said what you said. You just want to disagree for the sake of disagreeing. According to you, something is that which has shape. Yeah? If the something has shape, then the nothing has shape around it. Therefore, nothing is that which has shape. It's a stupid definition. Yeah, I agree with you. What you just said is a stupid definition. You didn't understand squat. Okay, so let's clarify. Here we have something on the upper right, and it's enclosed within nothing, which we call space. This fellow says that nothing has shape, so we want to know, because he says it has shape because it's encapsulating something, not because it itself is being encapsulated by the green stuff. And shape is what's on the outside, not on the inside, but he doesn't understand that, okay? So the issue is that he's got to identify the green stuff that is encapsulating nothing. Just in case, on the bottom, we get rid of the something and the green stuff, and we have only nothing. So he says that nothing has shape. Okay, and I put it as a circle or oval there. Doesn't matter. You can put a cube if you want. I don't care. I need to know what the white stuff that it's encapsulating nothing is. Okay, that's how simple it is. And here's our version of that. Okay, let me get back in here. Something, that which has shape. Okay, synonyms: object, thing, anything, body, structure, entity, medium, etc., etc., etc. Nothing. What is nothing? Nothing, that which doesn't have shape. So they're antonyms. Something is the opposite of nothing. Now we can use these words consistently, rationally in physics, physical interpretations, mechanisms, right? Because now we have defined these words unambiguously. Something, that which has shape, nothing, that which doesn't. Antonyms, no problem. Okay, nothing is the same thing as space. Space and nothing are exactly the same thing. Space is a word we give to nothing. Okay? So space is that which doesn't have shape. You can call it vacuum, void, nothingness, doesn't matter. All these are synonyms. Okay, something, you should be able to point at it in a single frame of the universal movie. There is no motion. Some people say, well, Bill, all objects, have electrons, and electrons are moving. These people are mentally handicapped. That's what they are. We're talking about a single frame of the universal movie. Nothing is moving in a photograph. That's what we have so far in front of us. We have location only. We have distance between objects. Distance and location are both static concept. There is nothing moving in that frame of the film. So even though electrons move every day from one time to another, from one motion to another, from one location to another, that's not what we're talking about. We're saying we're going to have a cross section of time. We're going to cut the universe right there at the cutting edge, which is of events, right? We call that the now, the present, whatever else synonyms you want to put in there. There is no motion in a single frame of the universal movie. Okay, so we have an object there. That's something. It's not moving. Not a single atom, not a single electron is moving there because we have a snapshot. Nothing moves in a snapshot, hopefully, unless you've drank too much beer. Okay, nothing is the one on the right, and there's nothing we can illustrate it with because you cannot illustrate nothing because nothing is that which doesn't have shape. See how simple it was? Okay. Okay, the first law of the universe, something can't morph into nothing, and nothing can't morph into something. There could have been no beginning to the universe, to matter, and there will be no end because hopefully something cannot turn into space. In other words, something cannot suddenly, spontaneously lose length, width, and height and become nothing. Likewise, nothing cannot acquire spontaneously, surreptitiously acquire length, width, and height and become something. Okay? Okay, we don't only have some of the etherists, we also have some other flatlanders around here, and let's look at them. Here we have one flatlander, and he says the following, okay? Says, well, he said this before, okay? This was a comment he put a couple weeks ago. Said, quoting Professor Muller from Berkeley University, that gravity goes right through things. And this fellow says, what? Like it goes through a wall? And so I had to clarify that what Professor Muller was referring to was Newton's equation. Force equals gravitational constant G, mass 1 times mass 2 divided by distance squared. Okay, that's the universal gravitational formula. Okay. And so when I explained that in the last lecture, then he put a different comment. He said, oh, okay, gravity goes through things like you, me, and the earth. Yeah, that's better. Okay, so now he acknowledged that gravity goes through things. That's what Newton's equation depicts. That's what it is describing. Okay? But then he says, but gravity pulls on things like you, me, and the earth. Total contradiction. No rationale, misspelled, right? Or reason given. Okay, let's find out. Let's continue here with this fellow. And he says, Newton's equation, a description, not an explanation of gravity. Absolutely correct. Yeah, he figured one out. Yeah, it's a description. Mathematics, any equation is only a description. Mathematics has no power to explain anything. That's why so-called mathematical physicists never explained anything. Okay, they never explain. They have no right to explain. They have no special insight to explain. They can describe mathematically, but they cannot explain the causes, the mechanisms. That's why we have all mechanisms today, all theories today coming from mathematical physics are irrational for invisible, intangible mediators, right, or events. Okay, he says, you have said nothing new to me. Well, I guess he wasn't paying attention because there he continues, says, you provide no explanation for acceleration of objects in your rope model. Changing only the angles of the ropes from a coaxial to fanning out, as demonstrated by your simulation, does not explain change in momentum. Well, I wasn't trying to explain change in momentum. I was trying to explain gravity, okay? He called it change in momentum. Maybe he was thinking about something else, okay? I was trying to explain the acceleration of gravity, okay? From a physical point of view, I was trying to explain a mechanism. I illustrated it. He didn't understand it. He says that the fact that I went from angles to fanning out, a single angle to, or a single coaxial to fanning out did not explain gravity as far as he was concerned. You state weight is static, correct. Weight is a static concept. Then he says changeless. I don't know what he means by changeless. I didn't say changeless. This is his irrational interpretation of what weight is static means. Weight is static means that weight is a static concept, means that you have weight for a single location anywhere in the universe. Anywhere in the universe, you have a given weight with respect to something else. Okay? And we'll get into that in a second in more detail. Yet, when the location of an object changes, weight changes. Yeah, see, again, he's talking about the word change. That's not what we're talking about. We're saying weight is static, and if you move to another location, static location, you have a different weight. Okay, so you do change weight. Okay, you do change weight. That's why this changeless is something he misunderstood. That is a description, not an explanation. Again, he missed the whole boat. Okay, an explanation that a child can understand like a rope pulling a donkey. Well, I guess he's got to go back to kindergarten because he did not understand the explanation, which was exactly like a rope pulling a donkey. Okay, and where does his ignorance and arrogance, right, originate? Well, it originates here, okay, and this is important to see in his case. Explanation is the domain of religion. Okay, so he thinks an explanation, a mechanism, right, of how something happened. For example, a kid threw a stone through a window, and we see the window on the floor, and we say, how did this happen? And a fellow says, well, a stone went through the window, or a brick went through a window. And that's an explanation. That's a mechanism of how the glass ended up on the floor. He says that's religion. Okay? Now he continues, says, neither Galileo or Darwin could explain their observations. And I'll include Newton there. Yeah, they freely admitted they only described what they observed. And yeah, all these people, mathematicians, they never could explain anything, so they only described, right? In the case of Darwin, I would make an exception. I would say that he did explain, okay? But I'm not going to get into that. My point is that in mathematics, okay, people like Galileo, Newton, they only described because all they did was equations. And in the case of Galileo, he did a lot of description, verbal descriptions without having to go into equations, but they were, again, descriptions. Okay, he never explained why, the causes of gravity. He just explained, this is what it does. And then he continues, says, religion, a topic of today, right, has a long recorded history of wrong predictions. Okay, I guess he's referring to general relativity and quantum mechanics, because general relativity predicted that matter arose out of nothing, Big Bang theory. So I don't know how that prediction, in retrospect, right? Retrospect prediction happened. I don't know how they can predict that a black hole, which is a zero-dimensional nothing, attracts, a star or swallows matter. So all the predictions of these people are wrong. How can a particle be at two places at once? So all these predictions from so-called science, mathematical physics, they're all irrational, let alone wrong. Many lives were, are, and will be improved because of better ways to predict events in the future. Well, I don't know what prediction has to do with anything at all, why he even mentioned this. What's it got to do with improvement? He's talking about, I guess, technology, and he thinks technology has something to do with science, okay? Without any explanation required. Explanations only satisfy those who demand answers that can't be questioned. Okay, again, none of that has anything to do with science. Science is exclusively explaining. That's what science is. You have to break your brain to explain, especially the invisible, intangible world of Mother Nature. And you don't have to believe it, but you do have to explain it. You have to explain the mechanism so that someone understands what you're proposing for how the universe works. So if someone says, how does gravity work, for example, why doesn't the Earth fly out of the solar system? You got to give an explanation to that question. And for that, you have to have a mechanism. It doesn't mean that the listener is going to believe in your mechanism. It means you provide one so that he understands what you're proposing. Now, you can say, look, angels are pushing the earth around the sun. Okay, that's your version. We understand it. You draw the angel, you show him pushing the earth around the sun. We understood it. Okay, we have your explanation for how you think the earth goes around the sun. No problem. But it doesn't mean that the listener is going to believe that explanation, but you do have an explanation. And for this fellow to say that all explanations are religion, obviously he's not going to understand anything that I teach here. I don't even know what he's doing here. He's got the brain to, to clean latrines at the bus stop. I don't know what he's doing in a science channel. Okay? What answers is he looking for if he's not looking for explanations? Okay, so let's explain to him what he missed. Okay, let's explain. Maybe the second time he gets it, you never know. Okay, or third time, because I think this is the third time. He says, "My stupid inquirers and arrogant assumptions make me laugh." Yeah, not only you, we're all laughing. So keep going. You're a great stand-up comedian. Okay. I don't mean to come off arrogant. Have some compassion, Bill. We all can't be geniuses like you. Yeah, these people are ultra arrogant and ignorant, and they say, "Oh, I'm not arrogant. I'm not," but see, it shows in every word that they pronounce. They don't fool anyone. Okay, so yeah, I don't have any problem with dealing with all these people. That's why when some people come here and say, "Oh, you said poo-poo, Bill. You called me a poo-poo." My God, grow up. That's all I can tell you. Okay, here's where we start. We have Muller, again, Mr. Richard Muller from Berkeley University, and this is what he said, okay? And I think I've got the link there. You can look it up. He says the following. He says, every atom on the earth is pulling on every atom of you. You're also pulling on it. The amazing thing about gravity is that it goes right through things. Okay, so what problem does this fellow have? He says, how can you be pulling at the same thing as going right through things? That's where he's got his what he thinks is a contradiction or irrationality in his mind. Okay, because again, he's thinking of particles probably, and he says, okay, the particle goes through you. That he can understand. Maybe they're invisible particles, whatever, and intangible particles. Okay, no problem. But then how do they pull? So this is what he can't understand, okay? So how do we answer, okay? Well, first, let's show an example here, okay? Here we see that the gravity, which is that yellow line, okay? We're just representing it with a yellow line. And what we're saying is that gravity somehow goes through everything, goes through the wall, goes through you, goes through the ball behind you, and keeps going. Whatever gravity is, it traverses everything. You can't put a shield in front of you, an anti-gravity shield, because it'll pull you right through the shield and the shield with you. Okay, so you can't shield yourself from gravity anywhere in the universe. There is no such thing as a gravity shield. Okay, anti-gravity, that's something else. That's called life. Okay, life is anti-gravity. But gravity shield, there's nothing in the universe. God has not invented it yet. Okay, and so here's the situation, okay? Here we have the earth, okay? This is what we're going to explain to this gentleman, okay? Here we have the earth, and we have it at two locations. We will assume, right, that the earth could be closer to the sun or much farther away. Case number one, you're far away. Case number two, you're closer to the earth, to the sun. If the earth is closer to the sun, assuming we could do that, if we could move the earth somehow closer to the sun, it would weigh more with respect to the sun than where it's at right now. Okay, that's what Newton's equation tells us. That's that distance squared in the denominator. Okay, do we have that? Do we understand that equation? The equation says that the farther away you are, the less you weigh. Okay? Okay, now, we need to clarify that it's a question of location. And again, we have to clarify that location is a static concept. Location occupies a single frame in the universal movie. Location is just a bunch of distances, another static concept, right, between atoms. We're not talking about distance traveled. we're talking about, which is the mathematical distance. We're talking about distance of physics, separation. There's separation between any two objects in the universe. Okay? So we're saying if we look at a single frame, not even an electron is moving in that frame. Nothing is moving. It's a snapshot. It's a picture. It's a photograph. Whatever other word you want to, painting, whatever word you want to use there. Okay, so we're saying that in one case, we're saying that weight is a static concept. There is no motion whatsoever. If you're just far away from the sun, you have a certain weight. And if you are closer to the sun in just a single frame of that movie, you weigh more. Weight is a static concept. There is no motion required for weight. Okay, I hope that, I don't know how else to clarify that for, at least for intelligent people. People who have mental problems, well, they might have a little bit of problem. They don't understand what I'm talking about. How do we explain this? How is it possible, okay, that if you're farther away from the sun, you weigh less at one location, snapshot? Not even an electron moves. Nothing moves. It's a cross-section of time in the universe. It's the now, the cutting edge of events. Any way you want to visualize that. How come you weigh less there and you weigh more if you were closer to the sun, static location, a certain separation from you and the sun, no motion, no electrons moves, picture, snapshot, same thing, same issue. How is it that you weigh less over here? How is it that you weigh more over here? We're not talking about motion. It's not that you moved, okay? We're saying if we take a snapshot, you weigh more here, weigh less here, and you weigh more here. That's what we're saying. Closer to the sun, you weigh more at a location. Static concept. Farther away, you weigh less. That's what Newton's equation tells you. The distance in the denominator is not distance traveled. There's no motion in that distance. It's separation between two masses which are in the numerator. Okay, someone following me out there? Okay, how do we explain it? Here we have it. We explain it with ropes. Okay, it's not only the angle as this individual insinuated there. It's more than that. We have more effective ropes. Okay, now the way I did it here, just for illustration, I showed fewer ropes on the way less on the scenario number 1, and I put more ropes, okay, on number 2. What did Mr. Richard Muller say? He says that every atom of the sun is pulling on every atom of the earth. Every atom on earth is pulling on every atom of the sun. That means every atom in the earth is connected to every atom of the sun and vice versa. What happens with these ropes, which are the ones that are connecting every single atom of these two objects? What happens when the earth comes closer to the sun? Well, the ropes fan out. You have more effective ropes. You have more effective ropes. The number of ropes has not changed in the universe. What changes effective ropes for this specific event? What do we mean by effective ropes? Let's go through that. Okay, here's the definition of effective rope. We have a cube and we have a cylinder. The cube has 5 atoms. We don't care about all the others. And the cylinder has 1 atom, number 6 there. Okay. All the atoms in the cube are aligned on the same axis, exactly on the same axis. Okay. They're all connected to atom number 6 along the same axis. That means all the ropes are superimposed one on top of the other, one inside the other. Ropes have no ability to touch ropes. Touch is forbidden in Mother Nature's universe. That is the assumption. Okay? So no ropes can touch another rope. They can superimpose. Just like in quantum, 2 particles can be at the same location, right? Here the same thing. 2 ropes can be exactly at the same location at the same time. Okay, do we have that? So we have one effective rope. As far as the cylinder is concerned, it just sees one rope because all these 5 atoms are on the same axis. What happens when the distance changes? It's not motion we're talking about separation. The separation chains. Suddenly the cylinder is closer to the cube. You see what happened to the 5 ropes. Somehow they fanned out. Now each one is pulling, you could say pulling, right? Individually, separate from the axis, okay, where they were before. So now you have what we call 5 effective ropes, and that's why the attraction of gravity is stronger, okay? So with those 5 different ropes, effective ropes, you pull more, or you have more stronger gravity than you had with one rope. Okay. On the right hand side, upper right there, you can see a general picture. 2 objects very far apart from each other. All the ropes superimpose and form a single coaxial, you could say. So if you know, you can look at maybe the nearest star. It's so far away that all the ropes superimpose, and that's why gravity is weak, because they all act like one single rope almost. Okay, what happens when the objects approach each other? Well, you can see what's happening to the ropes. They are no longer on the same axis. So it's not only the angle, it's that you have more effective ropes. Okay, so that's the theory. The reason for gravitational acceleration has to do with the ropes fanning out, and meaning that we have more effective ropes. You want to use another word, use another word. I use the word effective ropes. Okay. Anyways, all I can say to this fellow is, please try to understand before one of us dies, as Mr. Faulty Towers, Basil Faulty said in Faulty Towers, okay? So please try to understand before one of us dies, okay? And we do have our way of educating, of learning them, okay? We're going to learn you, okay? Yes. Anyways, that's the acceleration of gravity. Now, one person asked a decent question, okay, so we're going to address that one, okay, which is an important question. A lot of people have this in the back of their minds if they haven't asked so far. Okay, said, you said your ropes are non-tangible. So why would you say atoms are made your ropes when we know that atoms are tangible? Good question. The rope is pushed by the atom. Okay, well, not really pushed by the atom. Remember, the atom slides along the rope. But this, let's continue here. This means the atoms are tangible to the rope. It's not tangible. It's that the rope becomes the atom. Okay, so let's just clarify that. But that's not the question I want to answer. I want to answer the first part there. How can the rope be intangible and it creates something like an atom which is tangible? That's a valid question, okay, under the rope model. It seems that sometimes ropes are tangible, but sometimes they are not. For example, in the case of magnetism, ropes are tangible with each other. Not ropes, again, people are not paying attention. It's threads, okay? The rope is not a thread, the thread is not a rope. 2 threads are necessary to make a rope. You twine 2 threads, one around the other, you make a rope. You untwine a rope, you have a thread. People keep talking about rope theory and thread, bringing, rope into magnetism. Ropes are not the ones that are swinging in magnetism. It's the threads. Please get that right. It means you're not even paying attention. Okay? Okay, but let's answer the first part of this question here, or concern. Okay? First, we're going to consult Mother Nature. Let's ask her. Let's see how she does tangibility. Okay, because if ropes and threads are intangible, and they construct atoms, and they also, in the case of threads, they make up the walls that comprise magnetism, and you have some interaction there, then the question is, how does Mother Nature do this? How does she take intangibility and turn it into tangibility? That's what people want to understand. That's what they want to know. Okay, so let's ask Mother Nature, and she says, I produce tangibility through aggregation. Okay, we're going to produce tangibility through aggregation. Okay, that's how she does tangible. Okay, touchable, tangibility. Okay, what do we mean by that? Okay, here we go. Okay, here's the the construction of an atom. Okay, look at it carefully. Try to understand. We don't care if you believe or not. We want you to understand. That's very hard to get people to understand. Okay, here's the atom. How is it constructed? Okay, we have the electric thread that goes through the atom, forms the proton dandelion, a little star that's in the center of the atom. The center of the atom is not a little ball, or you could say it is, but it's made up of all these rays that are actually threads coming from every atom in the universe. Every atom in the universe. Okay, some people say, well, how can that possibly be? You got all these atoms in the universe, you got gazillions of them, and they converge upon our atom and built this tiny little thing with all these threads and ropes from every atom in the universe. Yeah, ropes do not have the ability to touch. Threads do not have the ability to touch. Until you understand that, you will not make any progress. Okay, so yes, they do not have you have to forget about touch. Okay, touch is our macro world, meaning atom and above. Okay, below atom, there is no such thing as touch. Mother Nature never invented touch for her mediators, which are the ropes which construct the atom. There you see the ropes impinging on the electron shell, the red line there. Okay, here you see it one more time. Okay, magnetic thread goes around, encapsulates the proton star, and comes out the other end as another rope. And you have all these ropes from every atom in the universe converging upon our atom. And one thread goes through the center, fills the proton star. Okay, and this is more or less what it looks like in big picture. Okay, so we got the construction. We don't want you to believe it. We want you to accept it as an assumption. Okay, this is what we're going to start with. We're going to put this assumption. Okay, so here we go. This is what our atom looks like. 2D on the left side, 3D on the right hand side. Okay, all the ropes from every atom in the universe converge upon our atom. One thread, we'll call it the blue thread, the electric thread. This is just arbitrary. Okay, goes through the center of the atom and builds this star-like entity. Looks like a rolled-up urchin, pointing its quills to every atom in the universe, right? And the other, the red one in this case, what we call the magnetic thread, goes around and encapsulates, the proton star. So you have a 2D version, you have the 3D version to get an idea of what we are proposing. Okay? Do you believe it? We don't care. This is what we're proposing so that you understand the theory founded upon it. Okay, here we have our atom. Okay, and again, you can see that the atom is, especially the electron shell, which is the encapsulating medium, right? The membrane. It's built by countless threads. Okay, do we have that? Thread from every atom in the universe, from every rope in the universe converging upon our atom. One thread, in this case, the blue or light blue thread, goes around, builds our electron shell, electron membrane. That membrane is going to encapsulate inside there the proton star. Do we have that? Okay, that's what we're proposing. Do you believe it? We don't care. We're not talking about belief here. We're talking about assumptions. We want you to recognize or understand the assumption so that you can follow the presentation and understand the theories founded upon it. Okay, here we move forward, and what you have to understand that those threads are not standing still. It's not a ball of yarn in a sense, okay? They're moving around, okay? So when we talk about, all these threads that converge upon our electron shell, the electron shell is a dynamic entity. It's constantly moving around because the threads are scanning, they're sweeping around the entire shell. So they're constantly in motion. That's why people think that the electron is moving, Okay, the electron in quantum mechanics is just one little dot, one location there, and they say, well, we don't know where it's at. Of course, you don't know where it's at because it's kind of like everywhere. Because the electron is not a tiny ball; it's a bunch of threads that are weaving around the atom, forming the electron shell, and the threads are in motion. They're sweeping around. They're swinging around the surface of the atom. Okay, so this is more or less what we're proposing. Do you believe it? We don't care if you do or not. The electron is not like that, and it's standing still. Okay, the electron has these um, threads sweeping constantly around. Okay, and I think at least we're proposing that the electron shell is pretty much as close as you get to a perfect circular or spherical object. Okay, now, I mean, it's rough surface. It looks more or less like that. Okay, so it's like a ball of yarn in that sense. But the yarns are dynamic. They're moving around. This thing is in constant motion. In fact, great speeds. Okay, so how about uh, magnetism? Here we have magnetism, okay? And again, how does she produce Mother Nature? She produces magnetism or what is called a magnetic field with aggregation. Is it with ropes? No, it's done with threads. Now we're talking about threads, okay? Do not confuse the thread with a rope. Two threads make a rope. Half a rope is a thread, okay? More or less, you got that? Okay, so here it is. We have the threads swinging around. I didn't draw all the threads. We're talking about gazillions of threads here, okay, from a magnet. But they're sweeping around like walls, okay, walls of threads. And yeah, when you have that aggregation, many threads forming walls, and all these walls sweeping around at great speeds, well, then threads go through threads, but at the same time they create this friction because of the aggregation. Here it is. Again, I haven't drawn every thread, so please do not criticize me for that, okay? Here it is. You have two magnets, okay? And you can see what the threads are doing. They're sweeping around. There's countless of these. And even though you see thread, we're talking about really walls of threads, okay? And they're sweeping around. When you turn the magnet around, okay, so that clockwise, well, first, we still have attraction when you just roll it sideways, but when you turn it 180 degrees, we can see what happens. They push each other away. Why? Because the threads are banging against each other now. Okay, so we have attraction, okay, both clockwise at the top, both counterclockwise at the bottom. Okay, you can see what's happening. If you turn it sideways, nothing changes. But when you turn it 180 degrees, we should have repulsion, and we do. Because why? Because now the threads are going in the opposite direction. Okay, so that's the mechanism. Okay, think of it as a flip book. Okay, here's a flip book. Okay, and you can see what's happening. We're saying that the threads form these pages. Okay, so that's your magnetic fields or walls that form the magnetic field, the whole thing. The whole book is the magnetic field. And it's something that goes on continuously. Okay, it doesn't stop. Yeah, unless it loses strength. Yeah, that's a long story. But think of it as a flip book. And what happens when you put two flip books side by side? Well, you get something like this. Okay, the one on the left is going counterclockwise, all the pages. Okay, and the one on the right is also going counterclockwise. What happens? When the pages on the right-hand side of the first one, of the one on the left, pages on the right-hand side go up, the pages on the left-hand side of the second one go down. And that's when they interact. Because what are we talking about? We're talking about countless threads forming walls which form the so-called magnetic field. Magnetic field is a dynamic entity. Okay? As Mr. Maxwell said, you know, in that region, magnetic field, there is matter in motion. Matter in motion. An exotic type of matter for sure, but matter in motion. Okay? And so, yeah, that's when you produce tangibility. You produce tangibility first when you have aggregation, in the case of the electron shell, okay, you have all these threads that are moving around. Okay, now you have a surface, so you can put one atom against another and it will touch. And likewise for magnets, you have two magnets. Here we have these two little magnets, okay? And what's in there are countless threads that you cannot see or touch, right, with your hand. Okay, you can touch them with iron filings, but you can't touch them with your hand, okay? Because your hand is not subject to that type of magnetic field there. That's a long story. But the point is, there you have a magnetic field. What did Maxwell say about a magnetic field? Well, there is matter in motion. That's what a magnetic field is. Don't talk to me about a static magnetic field, because even a static magnetic field has matter in motion. Okay, static magnetic field has matter in motion in there. And so what's happened? Why do they attract? Because one is going this way and the other one's going this. So they're both going in the same direction. Let's do it this way here. They're both going like that, right? So as this one comes down, this one's coming up. Okay, remember, this one comes down, this one comes up. That's what's happening. And that friction is what, countless friction, because you have one wall right after another. That's what pulls the magnets together. And the closer they are together, more threads, more walls of threads intervene, because now they're closer to each other. Now the atoms that are farther away are closer together also. Those are also engaging in the action. And now the strength of the attraction is greater. And the closer they are, more, you have a stronger attraction. So, it explains quite well. The rope model with the threads, swinging threads, explains quite well attraction between two magnets and repulsion. You have a mechanism now. But by saying, giving you an equation, we have described, but we have not explained how Mother Nature does that magic trick. Okay, so let's move on to religion, the topic of today. And what do we have for religion? Well, if you ask the man on the street, the first guy you stop, say, what is religion? He'll probably say that's something related to God, belief in God. That's typically what people have in the back of their minds. In fact, if you go to the Stanford Encyclopedia of Philosophy, you'll find like 4 or 5 articles on religion, different topics of religion. They all talk about the belief in God, how to prove God, does God exist? So everybody's got, anyways, in the back of their mind that religion has to do something with God and with believing in God, right? That's essentially what religion is from, you could say, a practical or pragmatic point of view. Okay, so this is what people think of when they think of religion. They think some kind of God out there, and they pray to this God, this thing out there, this human-like creature, anthropomorphic creature, and they pray for salvation, for favors, to win the lottery. Who knows what they pray for? Okay, so this is the general notion, okay, of what people understand by religion. Of course, when theists and people who do investigations, research on religion get involved, well, they say that's not exactly what religion is about, and they have more sophisticated notions of religion. But the first thing you have to understand is that at least that's the common notion out there. And some religions, like Buddhism especially, they pride themselves saying that we do not believe in gods or God. Okay? They have a totally different philosophy, idea of what religion is, or what their religion is about. They talk about consciousness and how to achieve enlightenment and all this other stuff, and say, well, they don't deal with gods, they don't believe in God. Absolute lie. Absolute lie. Buddhists believe in gods, whatever. Buddhists are no different than any other religion. Okay, so let's prove that to the Buddhists. Okay, people who say we don't believe in God, you're lying. You're not a Buddhist if you don't believe in God. Okay, so let's make sure that we understand that portion first. Okay, here we have the Buddha. He says, I don't believe in God, but I do believe in the Tripitaka. What's the Pali Canon, the Tripitaka? What are these? Well, they're the holy books of Buddhism. Imagine you find a Christian, somewhere, and you say, or say, for example, a Catholic, right? And you say, "What are you?" I'm a Catholic. Oh, you're a Catholic, yeah, but I don't believe in the Bible. How can you be a Catholic and not believe in the Bible? I mean, this is your holy book, so you cannot say that you believe that you are a Christian, but you don't believe in the Bible. And that's more or less what the Buddhists are trying to say here. They don't believe in God, but they believe in the Tripitaka. So is there any notion of God or gods or anything similar to gods, maybe angels, saints, spirits in the religion of Buddhism? Well, here it is. Okay, here we have them. This is the Tripitaka, the one of the Buddhist Bibles, or the main one, I guess. And there you will find at least one fellow. His name is Mara. That's what they call him. He's the Buddhist devil. Devil is a mean individual, mean God. Okay, and in fact, that's a stone picture, stone statue that they found of this Mara fellow. Okay, and yeah, he does a lot of evil in the world. Okay, so he's an anthropomorphic god that the Buddhists have because it's included in the Tripitaka, which is one of the main Buddhist Bible. So if you're a Buddhist and you believe in the Tripitaka, you cannot say, well, there is no God. And conversely, you can't say, well, we don't believe in God, but I do believe in the Tripitaka, which is my Bible. Okay, so you see where the contradiction is. And in fact, constantly you'll find all kinds of pictures in Buddhism. Here's one of them. Okay, and they show this six-armed Mara, the evil one. Okay, and this is how they portray him, like a, I mean, do you know if any human has 6 arms? Maybe there is one out there, maybe in the Amish community, But no, the Tripitaka does have ghosts and goblins and spirits and gods. Okay, and here's one. There's your illustration of one. This is what you'll find out there. Okay, they put this Mara fellow. Okay, he's a god of evil who tempted apparently the Buddha. Okay, just like the devil tempted God. Same little stories. So, they have had gods 2,000 years ago, okay? And 3,000 and more. In fact, we had what we call Greek mythology, and they had a god for every purpose. Okay, so when religion started, they had many gods. They didn't know what the wind was. They didn't know because they couldn't see it. They didn't know what rain was, and so they had a god for every purpose. Then later on, they came up with monotheism. They started having one god, but then some religions started having angels. Like the Christians, some Christian denominations. Same with Muslims. They believe in angels. And so they have one angel for every purpose. You can pray to one of the angels, one of your favorite angels. Maybe he'll listen to you and do something for you, that sort of thing. So, but that was hundreds of years ago. You talk about the generation today, Buddhists, Hindus, Muslims, Christians, and it's a different world. And you stop a guy on the street who's a Christian, who's maybe a Catholic or whatever, Orthodox, and he might say, well, I don't believe in that part of the Bible. I don't believe in I don't believe God created the universe, maybe, or that he created Adam and Eve. Maybe he believes in evolution, but he calls himself a Christian. Well, we got a problem because, either you're a Christian, meaning the original Christians, the ones who called themselves Christian, or you changed the religion and you became something else, but you didn't realize and you continue calling yourself Christian. Why? Well, I'll tell you why. Because they want to have the history of the book. They say, oh, our religion has been around for thousands of years. And here's the book to prove it. And that's on the one hand, but then on the other, they say, oh, but we don't believe in anything that's in that book because we have a new religion today. but they continue calling themselves Buddhists, Hindus, Muslims, Christians. So we have a problem. The people of today are no longer Christians, are no longer Muslims, are no longer Buddhists or Hinduists. What they are is something else than what people 1,000, 2,000 years ago were. Those people believed exactly in the literal Bible and their literal Tripitaka or whatever. They believed in that stuff. They believed there were some evil spirits rolling around. But today, a lot of people, especially the young generation, a lot of them don't believe in all that stuff, but they say, I'm a Buddhist. Why are you a Buddhist? Well, my father took me to church and I prayed and whatever. So they were raised in a Buddhist environment or a Hindu environment, and they learned by rote, by authority, to respect the customs, the traditions, and the religion. Some things they like, some things they don't. Sometimes, most of the time, they don't even read their holy books, but they swear on them, and so on. So these people are no longer Buddhists, they're no longer Christians, they're no longer anything. They've got new religions today. Just like, when religion changed from polytheistic to monotheistic, likewise today we have different religions that have nothing to do with what happened 2,000 years ago. Okay, this is the issue. All religions started by believing in God. Buddhists changed that. Now they're emphasizing behavior rather than, their gods, but their gods are in their holy books and they still, treat their books as holy. Period. We're done. Buddhists do believe in God. The traditional Buddhists, the authentic Buddhists. Everybody else is not a Buddhist. They should call themselves something else. Okay, and here you have a definition of Buddhist, okay, just in case. I'm picking on the Buddhists because they're the ones who claim that they don't believe in God, okay? Okay, here's Theravada Buddhism. Buddha refers to one who has become enlightened, through their own efforts and insight. I typically do it with a couple beers, okay, but yeah. A Buddha is someone who has realized the enlightenment that ends the cycle of birth and death. So a Buddha, the guy who's achieved enlightenment, he no longer dies or is born. I guess he lives forever, meaning he's a god. So the guy who calls himself a Buddha, there's 28 of them apparently in history. I don't know where they're at, because if they're not dead, I guess they're alive somewhere or whatever. If a Buddha is a guy who reached enlightenment, no longer is subject to death or rebirth, I guess he lives forever, meaning he's a god. Buddha is the same thing as God. In the Pali Canon, it is stated that Buddhas have appeared in the past and will also appear in the future. Okay, so now we're talking about this God coming to earth. I guess Jesus Christ, he achieved enlightenment, or he's the Son of God or whatever. Now he's going to come in the future, in the third millennium maybe, who knows. There were also numerous enlightened Buddhas who arose in earlier world cycles. So we've had pre-world worlds Buddhas. And the name of these 28 Buddhas are religiously preserved by Buddhists. Okay, so these people do believe in gods. They're known as Buddhas. The Buddha is a synonym of God. What is a God? It's a guy who lives forever, who has superpowers, meaning in this case that they achieved enlightenment, whatever that is. Maybe not physical, but mental, the consciousness stuff. And so they say, I'm a Buddha. I've achieved enlightenment. I've seen the light. So I'm a Buddha too. I've seen the light. It looks like this, okay? And I did that with 2 beers. So, okay. Anyways, let's find out what religion is according to the definitions today. Here's the religion. According to the dictionary, a set of beliefs concerning the cause, nature, and purpose of the universe, especially when considered as the creation of a what? Superhuman agency or agencies. Okay, so they're talking about superhuman, supernatural, transcendental. Okay, religion, the belief in and worship of a superhuman controlling power, especially a personal god or gods. That's according to the Oxford Dictionary. Again, you can see that they relate belief and God. They put those 2 words together, and that's essentially what the notion that people have of religion. Wikipedia says a social cultural system of designated behaviors and practices, morals, beliefs, worldviews, texts, sanctified places, prophecies, ethics, or organizations that, generally relates humanity to what? Supernatural, transcendental, and spiritual elements. I think that is a more generic definition than one in the Wikipedia. I think it's a notion closer to the person who does research on religion in general. You know, the normal guy thinks like the Oxford Dictionary, it's belief in God. The person who does a little more research, he said, well, it's not exactly belief in God, even though the Buddhists also believe in God. But assuming that it doesn't matter. It's more like the belief in the transcendental, in the supernatural. Okay, so we need to find out what these words mean if we're going to get to the bottom of the word religion. And we're going to distinguish it, for example, from mathematical physics. I mean, is that religion or is that science? What was science? Science explanations, rational explanations. Okay, here we have traditional religion, so we can summarize this. They propose that there are transcendental anthropomorphic beings, spirits, that intervene in human affairs. That's more or less their notion. You can, instead of beings, you can put in there things, objects, but it's related to the transcendental, okay? And we'll get to that in a second, what that means. Okay, and here we have the modern religion. We can call them, in the question whether they're religions at all. One is General Relativity, proposes that the cosmic world consists of an unimaginable, four-dimensional mathematical entity, okay? And quantum mechanics proposes that the subatomic world is mediated by reified concepts, such as wave function collapse, okay, so, or fields or energy, okay, there you have examples. General Relativity says that this is four-dimensional space-time. Why didn't I put something in there? Well, because we cannot imagine four-dimensional space-time. What am I supposed to draw? Okay, here we have quantum mechanics says this is energy. What am I supposed to draw for energy? Okay, so again, it's unimaginable. And that's different than what you see on the left, where, you know, the god of the wind, Aeolus, God himself, the one from the Christians, spirits, angels, we can draw those. You know, you can draw Casper the Friendly Ghost and say that's a spirit, that's a ghost. We can draw those. We can make images of those. What image are you going to make of a four-dimensional space-time? What image are you going to make of energy? What are you going to put on the screen for the, for the congregation to see? So we got a problem. The question is general relativity or quantum mechanics, do they even belong in religion? Or do we have a new category? You know, we had religion, traditional religions, that they said they believed in the transcendental. Objects, gods, spirits, angels, whatever you want to call them. So they say these spirits, these gods, they're acting in our world. They're interfering in our world. They make us think. They know what we're thinking. They listen to our prayers. They concede gifts or whatever you request. Sometimes they don't because they're angry at us, whatever. So, but we can picture all this. We can say, okay, this is the God, this is the angel, this is the spirit, and this guy is acting in our lives somehow by remote control, by magic, no problem. But we can visualize all that. We can visualize the part that they're referring to, the God, the spirit, the angel. In mathematical physics, you cannot even visualize the entities that they claim are performing all the miracles out there, like gravity, magnetism, electricity, etc. We cannot visualize it because you can't, they're all concepts that have been reified. So what are you going to put in there? So we may have a new category that we cannot really call religion. My son, Ans, he'll probably be here next week, and he says we should call it, what is it? Let me see if I can remember. It's the word escaped my mind. Okay, I'll have to pass because I can't remember the word now. And I got it in the tip of my tongue. I can't remember. It's what happens when you get too old. Okay, you get cough like I've had all these days. I've also got on this eye. Started the other day. Get a smudge that's moving around, a floater, and you get a little Alzheimer's to go with it. Anyways, it's authority essentially. You know, you believe in authority, and someone just tells you that space time is four-dimensional, and that's what causes gravity, and you just say, "Uh huh," and that's it, because you know this is what they teach you by rote. That's what I want. That's the word that I couldn't remember. Nazi. They're Nazis, like Hitler. You know, they're Nazis. What is it? They tell you you got to believe in this, you got to do this, and you just do it. You believe it, and that's it for mathematical physics. So, you know, it's this abstract world which they made into a concrete world. They reified the concepts, and that's a little different than traditional religions to a certain degree. You know, if you talk about God being a spirit, God being love, God being you know, intelligence or anything like that, a concept, energy, you know, then you're doing the same thing. But if you say that God is anthropomorphic, that the spirit is anthropomorphic, and that the angel, you know, has wings and a little plate on his head, then you're talking about a real entity that you can make an image of. You can't do that with anything coming out of mathematical physics. Therefore, you cannot give a physical interpretation because of that, because you don't have any physical, any objects to do the mechanism with. Okay. Okay, so yeah, in a way, we have to distinguish the supernatural from the irrational. Okay, and so here we have supernatural theories such as the traditional religions, Christianity, Islam, Judaism, etc. You know, and you have they believed in this transcendental world, and then you have irrational theories like mathematical physics, okay, and general relativity, quantum mechanics, modern philosophy, atheism, okay, agnosticism, ontology, metaphysics. All these are irrational theories. Why? Because they make all concepts, they turn them into objects. They reify them. That's when it becomes irrational. And in that sense, they're different than the supernatural. Okay, so what's the difference between irrational and supernatural? Well, here it is. Criteria for irrational is that you're treating concepts as physical objects. That's essentially what mathematical physics does. In that sense, you can say, well, it is a religion. It relies a lot on belief. You know, mathematicians talk a lot about belief, but that's not what distinguishes it from traditional religions. What changes there is that the modern religions, if we call them religions, of general relativity, quantum mechanics, string theory, mathematical physics in general, that includes also all the flatlanders, such as, you know, flat earthers, etherists, the electric universers, John Chappell group, all these people, they're in the same boat. You know, they are irrational theories because all these, you know, dissidents, they've copied the entities or the wording of mathematical physics. They use the word energy, they use the word charge, they use the word field, wave, you know, they use all the same language, and that's why they're irrational as well. And yeah, what you're doing is you're concretizing a concept. You're reifying a concept. You're turning it into a physical object. That's the main one. There's other couple others, you know, where you have no definition. People say that's word salad, as one guy suggested, or they have undefined words. Okay, ether is the main one we discussed today. Okay, so yeah, what we're saying is that maybe there's a difference between the religions of the last 100 years, general relativity and quantum mechanics specifically, with respect to traditional religions, in that they reify concepts. And that's a little different than having an anthropomorphic God or angel or spirit. Okay? Okay, we also have our science critic. Okay, and this fellow in this talk today, he talked about space-time. Is there such a thing as space-time? Four-dimensional space-time. Is it a thing? Can we visualize space-time? If space-time is a concept, can we visualize a concept? That's more or less what this fellow was talking about when he criticized one of my videos. And here it goes. Let me show you his part of it. Okay, and then we'll discuss it. Here it goes. Pay attention. The questions and issues to be addressed in this rebuttal include: is general relativity space-time a rational physical interpretation for gravity? And is it possible to visualize a mathematical concept such as space-time?
I mean, there is space-time, and the sun does warp that space-time, so that does cause the Earth to move around the sun. So there is a justification. I suppose we can try and visualize it, which we have done with space-time. There's a whole lot of different visualizations for that. But again, whether you can visualize it or not has no bearing on what's actually happening.
Okay, so this fellow believes in space-time. He believes that's an explanation, a mechanistic explanation for gravity. Okay, so he defends space-time. And so let's first go with an expert on space-time. His name was Stephen Hawking, died a couple of years ago. This is what Steve had to say in his book, A Brief History of Time. It is impossible to imagine a four-dimensional space. Okay? And so he says you cannot even visualize this. But people attempt to do so anyways, and here's typical scenario that people present. You'll see this quite often, just about everywhere. Just put space-time in Google, especially images, and you'll find something along these lines, okay? And here you'll see it, the moon going around the Earth. Why? Because the Earth pushes down space-time. That's that blue checkered ground on which the Earth is sitting there. This ridiculous two-dimensional platform or canvas or whatever that when the Earth pushes downwards turns into a three-dimensional canvas, you know, trampoline, fishnet, whatever you want to call it. And none of that is four-dimensional. So we're not looking at four-dimensional anything. The best we can see there is three-dimensional, okay? And this is the explanation that they have for gravity, why the moon doesn't fall, run out of the solar system or out of the Earth. It's because it's rolling around forever in this depression in space-time. So on the one hand, we have Mr. Hawking. He says you cannot visualize space-time. And here you have these people and they say, look, we can visualize it. And what we're visualizing is nothing that is remotely related to four-dimensional. It's a two-dimensional warped canvas that turns into three dimensions at best. And so that's not space-time. Space-time is four-dimensional. Where are the four dimensions? Okay, so yeah, you cannot visualize four dimensions, but this fellow believes that it has been illustrated. Yeah, he probably saw something like that and says, oh yeah, I saw space-time. No, you can't see space-time because first of all, it's a concept. And he doesn't even realize that. He doesn't realize that the word time is a concept. You cannot, what are you going to illustrate for time? A second, a minute, a year? What are you going to put for time on the screen? What are you going to show people? Okay, so you cannot visualize time. Time is the fourth leg of space. Time, obviously you cannot visualize a concept such as space-time. Here these people are illustrating it with this ridiculous two-dimensional canvas that turns into 3D. Again, it's not a representation of the 4D at all. Hawking tells you cannot even imagine four-dimensional space-time. So I don't know why these people are even trying to to illustrate space-time. Why don't they just do math and stay with math? That'd be fine. We wouldn't even hear about them. But see, they want to tell you that they understand why the moon doesn't fly out of the Earth or out of the solar system, out of the orbit, right? Or the Earth out of the sun. they tell you that they know why it doesn't, because space-time is warped. And you say, well, you show me the picture. And they say, well, we can't show you, it's an analogy. See, this is the problem. The problem is their analogy is you cannot even visualize, you cannot even imagine their analogy. That's the problem. They cannot illustrate it. And so, yeah, it's important to be able to illustrate these theories, because then you can see the mechanism. Right now we can't see the mechanism, because we see the mechanism for a three-dimensional object, not for a four-dimensional one. Therefore, we don't see the we don't see the analogy. Is a flat disk rolling around flatland an analogy also for four-dimensional space-time? Okay, what's keeping the flat disk from flying out? Okay, in two-dimensional flatland. Okay, is that an analogy also? So again, these people have no answers. And when you try to do that, when you try to use these pictures to try to simulate it, they laugh at you anyways. And this is from the establishment. It says, understanding gravity, space-time is like a rubber sheet. Massive objects distort the sheet. And the student says they distort because they are pulled down by what? And the teacher says, well, space-time is like this set of equations for which any analogy must be an approximation. So yeah, they don't have an explanation. Their analogy is worthless garbage. Okay, straight said the way it should be said. It's garbage. Okay, it's poppycock. But the question is, why do they even attempt to give a physical interpretation if they know they can't even visualize what they're saying? I mean, they should stick to equations and leave it at that. But when they try to give you an explanation, that's when they cross the line into physics. They tell you they know because they did their equations, and all they're giving you is their personal interpretation of their equations. And for that matter, we can introduce God and the angels and spirits as well. No problem. Okay, so what is the conclusion for this space-time thingy? Okay, here we have it. In physics, it is irrational to reify a concept and treat it as an object. Space-time is a mathematical concept. As such, it is irrational and misleading to represent it with a fishnet. In general relativity, gravity is equal to warped space-time. In physics, only objects can be warped or bent, because warped is a word that can only be applied to objects. When you say that the hammock is warped, hopefully you have a hammock. Hopefully you have a thing there, okay? And these people are warping a concept, specifically the concept known as time. How do you warp time, okay? How do you bend time? How do you break it in half, okay? And therefore, general relativity does not have a physical interpretation of gravity. And what you should ask yourself is, why did the relativists even try to give a physical interpretation for gravity or for how this universe works? If they have a description, mathematical description, no problem. Just keep it within math and don't ever bring it into physics. It's when they cross the line into physics that they have allowed people like me to question what they're proposing. And when they lose, when they have no way of defending themselves, they say, well, that's philosophy anyways. So they dismiss it anyways. Okay, so moving on here. We have some questions that people asked, comments that people made. Here's the first one. Phil says, energies have shape. Energies have shape. As an object increases in speed, so does the amount of energy. Oh, hold it. What do you mean amount? I thought you just said that energy has shape, meaning it's a thing. Draw it for us, first of all, but what do you mean the amount of shape? What has increased? Okay, so again, these people use this word salad. They're using word salad, semantic, because they're using nonsense. It's idiocy what these people are saying. Idiocy, what is it? Big ideas. That's what it is. Okay, energy is referred to as inertial mass. Mass can't go faster. Yeah, if energy is a concept, then obviously mass is a concept. It's very difficult to accelerate a concept. So I don't know how this fellow pretends to accelerate a mass when mass is not a physical object. You can say that he's going to accelerate a ball. He can accelerate maybe, a cube, an elephant, whatever, a house, but he cannot accelerate a concept such as mass or energy. Okay, so again, it's these people who have this word wizardry, word salad. They're using word salad. And it all comes from mathematical physics, which was driven into their brains, in high school, college, wherever. Okay, fellow says, light does not require a medium. But motion, two locations of a medium. That's what motion is. Otherwise, you got to define what motion is, okay? Because if light moves in any way, shape, or form, then it had better be a medium, okay? Any medium slows it down. Well, we don't care about that because the medium through which light travels has nothing to do with the medium that is doing the traveling. So this individual is confusing the medium that light is with the medium light is traveling through. Okay, so these are two different issues. The question is whether light itself has a medium that represents it, that is doing the motion. And hopefully it does, because motion requires an object, a medium. So how can you have motion without a medium? What is moving? So yeah, these people go around in circles, and when they lose, they can't answer the questions. They say, you're doing philosophy, you're doing word salad, you're doing word wizardry, etc. Because they can't defend their posture. That's what it is. Okay, well, it says, if I can't see electricity, what's lightning? Okay, so he thinks that because he sees lightning, he's staring at electricity. Yeah, but see, lightning, we look it up, it says a brilliant electric discharge. Discharge. What is discharge? Is discharge a physical object that you can see? Well, no, discharge is to rid of charge of electricity, according to dictionary.com. What is it according to Wikipedia? Discharge is flow of something, flow of current. So discharge is a verb, and you can't see verbs, okay, because verbs are concepts. Okay, so we can't see concepts, in this case, dynamic concepts. And so when you look at lightning, what you're looking at is a movie. You can't see lightning in a single picture, because that's not lightning, okay? That's just a flash, that's just a light, okay, that you've taken a picture of. Lightning is something in motion, because it's a discharge, and discharge is either rid of charge or flow of current. Okay, so you can't see verbs. Okay, that's what you're saying. It says, does lightning have shape, making it an object? No, lightning does not have shape, because lightning is in motion. Anything in motion does not have shape. Shape is a static concept. You have to take a snapshot of lightning. When you do so, you do not have lightning, because lightning is defined as discharge, which is a verb, okay? So you can't take a picture of running. If you take a picture of running, what you have in the picture is a boy standing up in the air somewhere, okay? That's what you have. And a boy standing is not running. And you say, well, but he's got his legs one in front of the other. Yeah, I know, I'm sorry, but running is a dynamic concept known as a verb, okay? And so you can't say that running, that you're going to take a picture of running, or that you saw running. Not in physics. In ordinary speech, you can say whatever you want. In irrational mathematical physics, you can say anything you want. Not in physics. In physics, we do word salad. We do semantics, okay? Whatever you want to call it. You have to define your terms perfectly rigidly, so that no one can go off on a tangent. Okay? And so he says, we can see and touch electricity. Well, if you can see or touch electricity, you could tell us what electricity is. Is it the flow of electron beads? Well, if it's a flow of whatever, you cannot see. You can watch it, not see it. See, you see a picture. Watch, you watch a movie. Okay? And touch, I don't know how you can touch electricity, but maybe he can. Maybe he's got super powers, maybe like God. Does the fact make it an object? Okay. Yeah, no, it doesn't, because see and touch have nothing to do with being an object. It's got to have shape. Shape is a static concept. Electricity is not. I invite you to stick your tongue in a light socket. So this all proves objects, such as what he thinks is electricity or lightning, by sticking his tongue in a socket. Hey, can you believe that? He says he's going to prove that electricity is an object by sticking out his tongue. My God, poor fella. Okay, here's another fellow says, if the magic rope is the invisible and intangible lines between atoms, and the black stuff is where atoms are not, okay, then by transitive property we can conclude that the black stuff and magic rope is the same thing. Oh my God. So these poor souls, they cannot tell the difference between rope and space. He's saying rope is equal to space by his what? Transitive property, intelligence, logic, whatever he thinks that is. Anyways, no, a rope is not equal to space. Rope is what connects any two atoms. Space is what gives shape to both the rope and the atom. Space is nothing. Space is the backdrop that gives shape to or you can say kind of cuts off objects from objects. If space weren't there, that separator, that thing that kind of distinguishes one object from another, we'd have a single block of matter in the universe. And yeah, that object would be infinite, made of a single piece, because it would not have space to chop it into the pieces we call atoms. Okay? Just as simple as that. And then final issue, fellow says, can we reduce all science to a firm distinction? In other words, both a concept and an object can be intangible. Okay, so let's clarify this. All concepts are invisible and intangible. You cannot see or touch a concept. You cannot touch running. You cannot touch electricity. You cannot touch lightning or see it, okay? Because these are dynamic concepts. Okay, they're verbs. You can't see verbs. You can't see running. You can't see flying. You can't see swimming. You can watch it. You can watch a movie of swimming. But what are you watching? You're watching, if you're watching flying, you're watching a bird. If you're watching, or an airplane, maybe Superman. If you're watching running, it could be a human. Maybe you're watching galloping a horse, okay? If you're watching swimming, you're seeing a fish. If you take a snapshot of that, that's not of any of those. You don't have a snapshot of flying, of running, or of swimming. What you have is a snapshot of a bird, a human, or a fish. Okay? So you can't confuse fish with swimming. You can't confuse human with running. You can't confuse bird with flying. And that's what these fellows do when they confuse electricity with motion, okay, with an object. They say electricity is an object, a thing. I can take a snapshot of it. I can touch it. No, you can't. You can touch a table. You cannot touch running. You can touch the boy. You cannot touch running. Okay? Electricity is running. Something's happening. It's a verb. It's a dynamic concept. So is plasma. So is ether. So is, lightning? All those are motion. You can't touch what is in motion. You can touch the object, not the motion it's doing, which is what these people are saying. Some objects are tangible but invisible, okay? Some objects are tangible but invisible. I can touch the air, but I cannot see the air, okay? Some objects are visible but intangible. Okay, you say, how can that possibly be? Yeah, the nearest star, Alpha Centauri, it's visible, but you can't touch it. And you say, well, because I'm not close enough. Well, won't know until you touch it, will we? Okay, and some objects are invisible and intangible. You can't see the table that the Klingon has on the other side of the universe. Okay, so it's invisible and intangible for us. Therefore, we can't say the table is not an object because I can't see or touch it. The Klingon's table. So table is always, the word table always represents a physical object. Okay? Word chair, the word tree, the word rock, all those are objects. Why? Is it because I can see or touch them? Certainly not the tree that's on the other side of the universe. They are objects because they have shape, and now we can apply the word, the definition, consistently across the board. With that, I'll see you next week, next Sunday. Hopefully I'll feel better with my